Every year, the world produces over 500 billion glass bottles. If you line them up in a single row, they'd wrap around the Earth more than 3,000 times. These are mountains of gleaming, fragile material that could remain in landfills forever, forming glass deserts for thousands of years. But a portion of this material gets a second, third, 100th chance at life. How exactly does an ordinary lemonade bottle, tossed into a recycling bin, pass through fire and mechanical hell to become crystal clear and ready for use again? Behind this lies a colossal technological process that rivals space programs in precision and scale. If you watch to the end, you'll discover the main secret of why glass is called the immortal material, capable of infinite reincarnation without losing quality. And it's precisely this property that makes it a genuine marvel of engineering and ecology. The journey to glass rebirth doesn't start at a factory. It starts on our city streets. Recycling begins with collection. In advanced countries like Germany or Switzerland, this is a well-oiled system where every citizen plays a part. Special containers for clear, green, and brown glass stand on every corner. Moreover, in many European countries, there's a fund system, a deposit included in the beverage price. By returning an empty bottle to a special machine at the supermarket, you receive a voucher that can be used towards purchases. This transforms rubbish collection from a duty into a profitable venture. In other regions, there's an entire shadow army of collectors, people for whom returned bottles are their main source of income. The collected glass flows along logistical arteries, from small trolleys to massive refuse lorries towards recycling plants. It's here, on these noisy and dusty sites, that the first act of its resurrection begins. After tons of glass bottles arrive at the plant, they face their first test, sorting. And this is where technology worthy of science fiction enters the game. Along a wide conveyor belt rushes a motley stream. Clear bottles from water, green ones from wine, brown ones from beer. The human eye can't keep pace with this speed. So optical scanners based on near-infrared technology are installed above the conveyor. A light beam penetrates through the glass while sensors analyze how it refracts. Artificial intelligence determines the chemical composition and color of each fragment in fractions of a second. Color sorting is critically important. Just one green bottle can contaminate an entire ton of raw material for clear glass, giving it an unwanted tint. After identification, the system issues a command. Powerful jets of compressed air shoot with surgical precision at the right fragments, knocking them off the conveyor into separate compartments. But color is only half the battle. Along with glass, the stream contains numerous foreign objects: metal caps, plastic rings, paper labels. Here begins multi-level cleaning. First, the conveyor passes under giant electromagnets. With a deafening clang, they snatch all steel caps from the stream. Then, eddy current separators come into play. They create a magnetic field that repels non-ferrous metals, like aluminum, forcing them to literally jump off the belt into a separate container. After this, powerful fans blow away light rubbish, paper and plastic. And finally, the glass passes through a water cleaning system where organic residue and dirt are washed away. Just imagine the complex journey every bottle we discard takes before becoming clean raw material. After sorting and cleaning, the glass is sent to its execution, the crusher. This is an enormous machine whose steel jaws or hammers grind entire bottles into small fragments with a deafening roar. The sound is as if thousands of chandeliers are simultaneously shattering. Several types of crushers exist. Jaw crushers that crush glass between two plates, and hammer crushers where hammers spinning at furious speeds smash glass against a steel wall. This stage's goal is to transform bulky and fragile bottles into a uniform mass called cullet. This material is far more convenient for transport and, most importantly, for melting. At this stage, any remaining impurities not removed earlier can be additionally screened out. After crushing, the cullet is sieved through a system of vibrating screens that calibrate it by size.
Even after crushing, cullet may contain microscopic metal or organic particles invisible to the eye, so it undergoes final, even more thorough cleaning. Magnetic separation here works at a new level, capturing the tiniest metal inclusions. Then special optical technologies are used to remove ceramic or porcelain remnants, which look like glass but have different melting temperatures and can cause defects in the finished product. This guarantees that absolutely clean material enters the furnace. Then the glass crumb is sent to vibrating sieves, where it passes through several levels of screens with different mesh sizes for separation into fractions. Different grain sizes are used for different types of products. This entire process is fully automated, minimizing risks for workers.
After all stages of cleaning and calibration, the purest cullet is sent to the factory's heart, the melting furnace. At the plant, it's loaded into gigantic furnaces where it melts at temperatures from 1530 to 1650 degrees Celsius. At such heat, glass becomes liquid, viscous, and fiery red, like lava. Adding cullet to the melting process is not just ecological genius, but economic genius too. Recycled glass melts at a lower temperature than primary raw materials, sand, soda ash, limestone, which reduces energy consumption by 30%. Sometimes a small amount of new raw material is added to the melt to adjust the chemical composition and guarantee the strength and transparency of future products. After the glass transforms into a uniform liquid mass, its rebirth begins. The molten lava is directed into forming machines. Here, a drop of molten glass under air pressure transforms into a new bottle, jar, or vase in seconds. At large plants, this process is fully automated and can include high-precision molds to ensure perfect quality. Immediately after forming, the red-hot glass products pass through a long annealing tunnel, where their temperature gradually and very slowly decreases. This is a critically important stage that relieves internal stresses in the glass and prevents cracking. After forming and cooling, new glass products undergo ruthless quality control. Special robotic systems check every bottle for the slightest defects, air bubbles, micro cracks, uneven wall thickness, or incorrect shape. Optical scanners and lasers illuminate the glass, revealing flaws invisible to the eye. If a product doesn't meet the highest standards, it's ruthlessly rejected and sent back for remelting. Then, bottles are tested for mechanical strength, checking whether they can withstand the pressure of carbonated drinks and impacts during transport. Only after passing all these tests are new glass products packaged and dispatched to market. Thus completes one cycle of their endless life.
Every minute, thousands of kilometers of old cable vanish from our world. They're torn from the walls of houses, factories, and machines. And all of this scrap is reborn as pure copper, a hidden treasure more vital than gold for our modern world. Imagine it. Coils of wire that yesterday lay forgotten in a scrapyard are today melting in a furnace at over 1100 degrees Celsius, hotter than a volcano. But the most remarkable part? Copper can be reborn infinitely. So the wire that lit your room 20 years ago might be powering an electric car tomorrow. And stay with me, because at the end, I'll reveal a secret this metal's been hiding, and it will change the way you see copper forever.
Every wire you see around you, from old charging cables to industrial coils, has a story. It was part of something, conducting power, carrying signals, bringing things to life. But time moves on, technology is upgraded, machinery replaced, and these cables become waste. But this is where their second life begins. The scrap is gathered from everywhere: homes, offices, demolition sites, even old vehicles. A vast, unseen logistics network of lorries, containers, and depots comes to life. It's a treasure hunt, but the prize is metal and plastic, twisted together in a tangled mess. The first stop, the factory floor. Here, the cables pass through the hands of experienced operators who aren't just sorting, they're industrial archaeologists.
This is a critical stage. The quality of the final product depends entirely on the accuracy of this sort. Mix the wrong types of metal, and you compromise the purity of the copper, complicating every process that follows. The team here uses a variety of tools: shears, pliers, and specialized stripping machines. The work is fast, but precise. Every coil is unwound and separated into fractions: bare bright wire, plastic-sheathed cables, thick industrial lines, copper, and aluminum. The integrity of the copper must be preserved. It's the heart of the operation. Even the smell on the workshop floor, a mix of old plastic, metal, and dust, tells you that this is where the transformation begins.
The coils are separated, the wires untangled, but the real alchemy is yet to come. What were once kilometers of cable are now fed into the heart of the plant. Some call it a shredder, others a dragon with steel teeth. The principle is the same. This beast devours everything. Cable fragments are loaded into a vast hopper. Inside, shafts armed with razor-sharp blades don't cut, they chew. Copper, aluminum, plastic, it's all torn, crushed, and ripped into small pieces. From there, the shredded mix enters a machine where physics takes over. A symphony of centrifugal forces, vibrations, air currents, and magnets goes to work. The light plastic is blown away into one stream. The heavy copper falls into another.
The air is thick with dust. The hum of machinery is constant. Operators watch the metrics on their screens intently. This isn't just noise, it's the sound of rebirth. Just like the alchemists of old who sought to turn lead into gold, there are formulas at work here too. But instead of elixirs, there are weighing systems, calibration tools, and purification technologies. Because in the modern world, magic is just well-engineered technology.
Inside the furnace, fluxes are gradually added, special agents that bind to impurities like oxides, dirt, and residual insulation. They float to the surface, forming a dark crust of slag. This is skimmed off by hand with long ladles, in a heat you can feel through a protective suit. It is one of the most dangerous jobs in the plant, but also one of the most majestic. Here, people witness the purification of old metal with their own eyes. They watch rusty scrap transform into a molten lake that glows like the sun. Even the sound is different here, a deep, guttural, threatening hum. It's the sound of copper saying, "I am returning."
Once the molten copper is cast into solid ingots, it still doesn't know what it will become. Its future lies in the hands of engineers and the rolling mill. The ingots are transported to the mill, reheated, and then forced through a series of giant rollers, like flattening a piece of red-hot dough. With each pass, it gets thinner. With each pass, smoother. This is how copper sheet is formed, or the feedstock for wire. Next comes drawing. This is where the copper is pulled through a series of progressively smaller holes, or dies. It stretches, thins out, but never breaks. Each die brings new precision, measured in microns. All of this to create a thin, flexible, gleaming copper wire. Sometimes, this wire will be insulated and buried in the walls of a new house. The average home requires around 200 kilograms of it. Sometimes, it will be wound into the motor of an electric vehicle. And sometimes, it becomes the delicate coil in a pair of headphones, carrying music from one heart to another. Every minute, over 17 tons of copper scrap are recycled globally. It's a metal that can be repurposed almost infinitely with no loss of quality. It lives, works, melts, and begins again.